What I will be discussing today is the sum and difference of two binomials, which actually results to a difference of two squares. Now, this happens only if you have the first and the second term, which are the same with each other, but one is expressed as a sum and the other one is expressed as a difference. So we have x plus y, the other one is x minus y. So if we have observed that the first term are the same, and then we have the second term, they're also the same, but one is a positive and the other one is a negative, the short method for that is we simply have the square of the first term, that is x raised to the second power, and then minus y raised to the second power. We can actually prove that by simply making use of our FOIL method. So x plus y, quantity x minus y. If we are going to apply our FOIL, which means we have to multiply the first term, so that is x with the x, and then y with the negative y. So there will be x squared as the product of x with x, so that is giving us a product of x raised to the second power. And then you have the y with the negative y, so that is equal now to negative y squared. Now, what happens to the middle term? Okay, you will notice that you have a product of a positive xy here. So that is positive xy. And if you are going to multiply the x with the negative y here, which is our last now, then that is a negative xy. So the relationship of your xy and negative xy are additive inverses, which means that this will result to 0, meaning they are already cancelled. And so what stays or what remains is just simply the x squared and the negative y squared. Okay, so that if you are going now to apply this in some binomials wherein we have the sum and difference, all we have to do is to observe. So it's very important that the first term are the same. So we have 3x and 3x, while the other one is an opposite of the other. So positive b, and we have the other one is negative b. So all we have to do is to square. So 3x, 3x, because the rule is satisfied. So we have 3x with the 3x is 9x raised to the second power. And we need to subtract that with the square of our second term, which is now b. So b raised to 2. That goes with this one also. We have x squared with x squared. We just have x raised to the fourth power. And then 8 with the 8. Taking that negative, so negative 64. That is the result. And for the quantity ax plus by multiplied by quantity ax minus 7b, so we simply have a raised to the second power also. A squared, x squared, and 7 with 7 will now give us a negative 49 there, and then the variable b raised to the second power. And taking or answering now our fourth problem, we have again x cubed, they are the same. Then we have positive 3x, the other one is negative 3x. So we can use the rule. So x raised to 3 multiplied by x raised to 3 will just be x raised to 6. And 3x with the negative 3x, that is now equal to negative 9x raised to the second power. And last, we have 8x positive or minus 1 multiplied by 8x plus 1. So 8x multiplied by 8x, that is 64x raised to the second power. And the square of 1 is negative 1.